expectations and the expectation for the dose levels. So next, as a linear combination in 3 examples, well, we can do a multiplier. So here's the expectation of 16 times the dosage. When we do that, when we have a multiplier as a linear combination, serving it as the expectation as our analysis tool, we can actually move it out like a constant to the left. So we can left factor that 16. We've already computed our expectation of dosage, which was 14.39. So what we're going to get is 230.24. Well, what does that mean? What does that translate into? If we get 234, it means that, well, not only do we have the case, the expectation if we draw a random case, before it was a 14.39, well, if every case was given 16 times the amount of dosage, then we can see we can just left factor that 16, locate it on the left, before we proceed with that multiplier, and it will be an average now of 230.24 milligrams. For exercise 2, we're going to combine variables R and B by addition. And this is a little unusual because recovery rank is often not a quantitative variable, but qualitative. So here we go. Well, it turns out for expectation mathematically, our expectation of the ranked recovery cases was 2.19, plus we have our expectation of the dosage given was 14.39, and just doing a little mental math, that would be 16.58. Now notice the units problem, we really don't have a milligram unit for our recovery variable, but we do have that assigned to dosage. So it may be sufficient to leave it in place as unrelated units as a linear combination. Similarly, with the difference of these two variables compared to the joint distribution, we will take the ranks of recovery compared with dosage, which is measured in milligrams. Okay, again, as a student exercise, notice that we still have the recovery rank expectation of 2.19, and we also have the dosage in milligrams of 14.39. So when we take the difference, we would get negative 12.2 for this parameter. So just as a word of warning, when you do a linear combination, a aX plus b transformation of your expectation variable, remember that often in joint distributions we have unrelated variables, meaning they're based on different units, or one is quantitative while the other is qualitative, but we can compute numerical values for each.